All right, so in this lesson, we will convert large numbers. So we're going to convert large numbers specifically between something called scientific and standard notation. So we're going to take a large number and we're going to make it look we're going to write it in different ways. Before we do that, let's learn how to rewrite repeated multiplication. So 10 times 10 times 10 times 10. Another way of writing the expression above is 10 to the fourth power. I'll make that 4 a little smaller so you can tell. Fourth power, exponent. Another way of writing the expression above, expression is 3 to the second power. Another way of writing the expression 4 times 4 times 4 is 4 to the third power. Another way of writing the expression above is 5 to the fourth power. And this would be 6 to the second, and this would be 7 to the 1, 2, 3, 4, 5. 7 to the fifth power. Remember, this only works for multiplication. This won't work as 10 plus 10 plus, because you write addition as multiplication, but you write repeated multiplication as exponents. All right, so let's rewrite this a different way. So 3 times 10 times 10, we can write as 3 times 10 to the second power. So 3 times 10 times 10. 4 times 3 times 3 times 3 times 3, another way of writing the expression above is 4 times 3, 1, 2, 3, 4 times. Another way of writing 5 times 2 times 2 times 2 is 5 times 2 to the third power. 5 times 2, 3 times. So we already know that. I'm not going to write the whole thing. I'll write it this one time, I guess, but another way of writing the expression is 3 2/10 times 10, 1, 2, 3, 4 to the fourth power. 2/3 times 5, 1, 2, 3, 4, 5 times. So it would be 2/3. I'm going to write my times like this. Times 5 to the fifth power. 6 34 times 1. I'm going to write it again like that. Times 1 to the third power. In this part of the lesson, we are going to determine whether a number is in scientific notation, regular notation, or in neither. So remember, well, first off, scientific notation, you'll always have one single number, one single digit number. So this is like 1, 2, 3, 4, 5, 6, 7, 8, 9. But this is not 10 or 11 or 12. You'll just a single digit. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, and it's not 0. So it has to be a single digit 1 to 9. And then you have a decimal, some numbers. Remember that this isn't always required because there's always a decimal, there's always numbers. It's like 0.0, so to speak. And you'll always have times 10 to like a number. So let's look at this first one. This first one is just a regular number. There's nothing special about it. It's just 5,400. This is standard. So it's called standard notation, regular number. In this one, we have a single digit between 1 and 9, or from 1 to 9, which is 3. We have a decimal and some stuff right here, some, just more numbers. And we have times 10 to a power. So that is scientific notation. In this one, we have a negative number. That's okay. It's still a single digit, 1 to 9, 1 through 9. We have a decimal and a number times 10 to the 6th. This is scientific notation. Now, look at example 19. The first thing we run into is this 25. This is the problem, because it has to be 1, 2, 3, 4, 5, 6, 7, 8, 9. This is all the way up to 23. So this is not scientific, but it's not a regular number. It's just neither. Okay, so in this one, we have a single digit, which is 1. That's fine. We have some decimals. That's fine. This 10 is the problem. So this isn't scientific, but it's not a regular number, so it's not standard. It's neither. And on example 21, we have negative 5 times 10 to the negative third. So negative 5, that's fine. There's a decimal with some stuff. It's just 0, right? And we have 10, and we have, even though we have that negative, it's still, it's fine. It's okay. So it's scientific notation. Let's look at this last section. So we're going to convert a number written in scientific notation into standard notation. So we have 3 and 87/100 times 10 to the third power. Now remember, this really means 3 and 87/100 times 10 times 10. Well, I want to put it like this. Times 10 times 10 times 10. Remember, this is times 10 times 10 times 10. So this number is actually being multiplied by 10 3 times. So the decimal will move 3 spaces to the right. So let's just go ahead and do that. 1, 2, 3. Don't forget to write your decimal. Don't forget to write the arrowhead. Don't forget your zeros for placeholders. So the standard number was 3,870. The scientific notation was 3 and 87/100 times 10. I'll write that in the middle a little better. Times 10 to the third power. Example number 23, we have negative 5 and 4/10 times 10 to the fourth. So remember, we can write this as negative 5 and 4/10 times 10 times 10 times 10 times 10, because it's 4 times right there, like 10 to the fourth. So this number is being multiplied once again by 10 4 times, so the decimal will move 4 spaces to the right. So let's do that. 1, 2, 3, 4. Oh, I almost forgot the decimal. Okay, so in let's start with standard. Our standard notation is negative 5, 4, 0, 0, 0, so negative 54,000. And our scientific notation is negative 5 and 4/10 times 10 to the fourth power. And on to our last one. We have 2 times 10 to the fifth. Now remember, this is fine. This is just 2.0 times 10 times 10 times 10 times 10 times 10. 1, 2, 3, 4, 5 times. So the number is being multiplied by 10 5 times, so the decimal will move 5 spaces to the right. So 2, 1, 2, 3, 4, 5. Don't forget the decimal. So standard notation would be 2, 0, 0, 1, 2, 3, 4, 5. 3, 4, 5. And we can put the decimal. So that is 200,000. In a scientific notation, it's 2 times 10 to the fifth power. Now, some of you might be tempted you see how it's 5, 10 to the fifth? Some of you might be tempted just to write 5 zeros, 1, 2, 3, 4, 5. But in this one, it was to the fourth, and we only wrote 3 zeros. So that trick's not going to work. Let's look in that one before that. 10 to the third. So you would think 3 zeros, right? But because it went under 2 numbers or 2 digits that were already there, we only wrote 1 0. So don't just try to count the zeros, okay? Thank you.